Here is a graph that shows the price of blueberries at two different stores. Which store has a better price? We can compare points that have the same x value or the same y value. For example, the points 2, 12 and 3, 12 tell us that at store B you can get more pounds of blueberries for the same price. The points 3, 12 and 3, 18 tell us that at store A you have to pay more for the same quantity of blueberries. This means store B has the better price. We can also use the graphs to compare the constants of proportionality. The line representing store B goes through the point 1, 4, so the constant of proportionality is 4. This tells us that at store B, the blueberries cost $4 per pound. This is cheaper than the $6 per pound unit price at store A. Imagine that a faucet is leaking at a constant rate and that every 2 minutes 10 milliliters of water leaks from the faucet. There is a proportional relationship between the volume of water and elapsed time. When we have two quantities in a proportional relationship, we have two choices when representing the relationship. We could say that the elapsed time is proportional to the volume of water. The corresponding constant of proportionality tells us that the faucet is leaking at a rate of 1/5 of a minute per milliliter. We could say that the volume of water is proportional to the elapsed time. The corresponding constant of proportionality tells us that the faucet is leaking at a rate of 5 milliliters per minute. Let's use V to represent volume in milliliters and T to represent time in minutes. Here are the graphs and equations that represent both ways of thinking about this relationship. Even though the relationship between time and volume is the same, we are making a different choice in each case about which variable to view as the independent variable. The graph on the left has V as the independent variable, and the graph on the right has T as the independent variable.